Now, yeah, please go ahead, because I think the session, we've just started the session. So if you want to say a few thanks.
On behalf of, before some people leave and so on behalf of the project and everyone here, everyone online, I would like to say thank you to. Oh. Hi, it's Gerhard Robeck here. On behalf of the OntoCommons project and everyone here and everyone online, I'd like to say thank you to the Trust IT colleagues and also to Ernst Janotka, who have been organizing this event, and all of the the technical things, sometimes not so easy, but they've always worked hard to make it all work in the end. And so thank you very much for everyone, from everyone for your organization and for your support. Then also for the local people. Monia is also here. Yeah, I think I can see her. So thanks very much also to you for your support with the organization.
Thank you.
And all of the food and everything that you did. Thank you. So over to you.
Thank you, Gerhard. So I can repeat it, Monia. We are extremely grateful for all your hard work. In fact, Monia had to deal with a sort of a health issue yesterday, even after having been on her feet 14 hours per day and running around. So we are hugely grateful for all this effort. And Gerhard was just thanking our colleagues from Trust IT and also Ernst Janotka from TU Wien, and especially you on a local level here, where you've been running around and making sure that people have fantastic food and everybody's catered for, and that everybody gets whatever they need. I mean, it's been really fantastic. It's been a great week, so thank you very much for that. One more round of applause for everyone. So we are going to now start with some of the very exciting work that has been produced both this week and also the work that this has been built on, which is also rather novel, and it connects also very uniquely to the keynote that we saw this morning. Some of the work is actually referencing now the new IP ontology. We have several presentations. Some of it is the result of hands-on prototyping, like the first one you will see from Andreas Rudenau, who is here to represent both the Wasserhauen use case and the work with ICF that has been done in Ready. And then we will go on to the IKEA use case, which has been hugely exciting. We will have, after that, some presentations of new uses of tools for ontologies as well, that have been the students have been working on, and also LAN has done some modifications so some very interesting pieces of innovation that have happened this week. So the first person, and I have now lost. Oh, there you are. Sorry, you're hiding behind the monitor. So the first person, as I already mentioned, is Andreas Rudenau, who will also use live streaming to show the demo. So we are hoping that the data will load and that everything will work smoothly, but do bear with us in case there are a few kind of moments when we have to wait for data to load, because we are doing this live. So a round of applause for Andreas Rudenau.
Is it okay? Yeah, thank you so much. Yeah, indeed, now we will stream data here to this session to show a little bit of the prototyping that we have been doing this week. And I must say it has been really great to work with this kind of way of sitting hacking. At the same time, we have the experts talking about interesting things, and it's possible to ask people about the ontologies and stuff like that. So it's really great, and I think this concept should be explored more. Also, I think that coming from outside the ontology community, as a software engineer, I think we can do more when bringing together people from outside, and also work how we can boost the ontologies also. So I'm really happy about this this event. So I'm Andreas, and I'm going to present now a few things about the Basachan project. As you have seen me coming here and talking about this supply chain thing that we need to digitalize, so that we can.
Sorry to interrupt. Yeah. Apparently, you need to mute your own computer because you're being heard twice online.
I think we already fixed it.
You fixed it.
Yeah,
okay.
But check for just to be sure, because I saw that. Yeah. So I hope that you have a good sound and no echoes anymore. So the Basachan project, as you see, it spins around there on the screen. It's a very challenging project when it comes to interoperability because we're covering a whole supply chain, and this is we need to do that. We need to cover the data flows between the actors to be able to take more responsibility for the environment, measuring different indicators, especially looking at different CO2 targets and where the energy goes and who has responsibility for the different environmental aspects. So I will today I will show you a little bit of the Basachan data. You can see the building they're spinning around on the nice video. This is the real building we have built now in France, and I will load this model specifically now and work with it a little bit to connect it to ontologies. Then before that, I want to tell you a little bit more about the journey that we had before coming here. I have been participating as a demonstrator in the OntoCommons project, also with the ICF. We have been working in the READY project, and there we have been working on very similar things, streaming data from manufacturing. And I can just show you a little bit of the prototyping here we have done with streaming manufacturing data coming in. A lot of instances going on here in a supply chain, manufacturing chain, and these are all batches representing the manufacturing flow for polycarbonate sheets going from the raw material to the building roof components. So as you can see, there are many nodes that needs to be loaded at all time. And another more maybe intuitive view of this is the flow looking from this perspective. So we you can see now that all the instances are loaded, but they are shown in a flow from the left to the right in the supply chain, going through the actors in the supply chain, and where we can see how much of the raw material going in to further into the pipeline, and also what's going out in waste and in repurposed material for the circular flow. So this is super interesting and a very intuitive way to look at this kind of manufacturing flow for circularity. Going back now to the other more maybe familiar for you, with the node, the graph visualization, we can see here how we are drilling down in these instances that represents the batches of material to check on the semantic connections. And here we are showing the specific connection we are doing from these instances into the ontologies. So for this polycarbonate instance, you can see what it is. So it's a sheet for a recycled batch on the application level, and then we are connecting it into the supply chain ontology of IOF. And further on, as you know, this is connected to the BFO ontology. And then on the other side, if we are following it now, the same instance on the other side, we are now connecting to the IP ontology that we heard Tervel talk about here before. So we are actually looking at this instance from the two perspective and chaining this IP asset that comes from the legal ontology back into the IOF supply chain and the IF4 and the BFO ontology. So what I wanted to do during this week is actually to work with the Basachan building to see if I can do something similar And for that, we are using the platform in Basajaun that you can see here. I'm just going to join. It's called Wood Launch, and this is what I'm promoting this week. It's a live streaming platform for node-based data and semantic data that we are using for people that doesn't know what ontologies are. So basically, we need to discuss with them about semantics from the very beginning. So what we are doing is that we are loading nodes on a canvas in real time, so everyone can send nodes to the canvas and then examine the different connections. So we have some presets as well, so we are presetting it with forest theme, so everyone feels comfortable coming from the wood supply chain then. And yeah, then we can look at it in 3D with these cute 3D models, and everyone knows what a thing should be. And looking at, for example, then we are working with a downstream relationship to see how we are sending things along the chain. But then we, of course, are showing some properties and agreeing on what kind of properties do we want to cover. So as you're sending these nodes and these properties, it will update in real time. So we can play around a little bit and see how we feel about it. And of course, then everything is connected to with semantics because this is linked data. So everything has a type and a namespace and so on. So we can work with it and then formalize it maybe in another tool for ontologies if we want. So going from this now into the playground and using this platform for the exercise for this week, I'm loading the buildings from Basajaun into these nodes, and there are two buildings, the southern and the northern building. Let me see. It's a little bit tricky because I'm having another device to send the data from, so that's why you cannot see what I'm clicking. But I'm sending the signal, and then it's loading in this application here. So that's why I look a bit confused where I should click. But if everything works now, we will load. Yeah, we will load the buildings. So these are CAD models then, and here you can recognize now the data that the building that you see here on this video. So it's exactly the same model that you can see, but it doesn't look really that nice here in this environment, but that's because of the rendering, of course. Yeah, so what I did now is that I wanted to break this building down into the semantic components, and then I can see if I can load now the different parts of the building like this, and what it is, and then I need to reload and sort the building on the 3D data on their nodes, and this takes a little bit of time now because now we have to split the building and move it to the right position. So you have to bear with me here, and I will also show you now something very interesting that you might not see if you're just looking at this small tiny building. It looks like not much, but it's still loading. But I can show you this discrete accessory here, and of course I have to load one of the buildings that are not that big, because if I take another building, it would definitely not work. Let me see now. So I know that soon it will start to react again to you, and we will go down to see at the discrete accessories. It's really like if you're looking at something, but you do not see it, but it affects everything so much. So here are all the bolts in the structural model for the southern building, and the northern building is like 100,000 or something like that. So I cannot load it actually, but these are super small bolts, and we are loading all of them, and we have a lot of instances here. So it can be kind of interesting to see how many instances we have and what type it is. Looking at this again, we can actually load the IFC ontology and try to map now the instances on top of that. So if I just remember what button I should click here, I will load like that. I see something happen, but yeah, you can see the log here, what happened. So I loaded the file, the turtle file into the application, and I want to show now the all the classes. Yeah, so the IFC is yeah, the ontology. I wish, yeah, it was easier. I wish they could clean it up a little bit to only use or split it up something so that we use what's most common, because these are all the classes and there are thousands of them. And I think this is not even all the classes, but now I want to do the experiment to actually feed the instances on the classes with extrusion, so I can see where we have stuff. So you can see now there are some columns coming up from the classes. Yeah, so it's animating there, and I have one there. It's really huge, and I already know which one it is. It's the most infamous class in IFC. It's the building element proxy, which means that put everything here that you don't want to know what to do with, and then you have no semantic connection at all. So that is what happens with the CAD software. They are horrible at exporting the stuff properly, which is bad. So I hope that we can fix this in the industry in the future to really make proper semantics into the models, so that we can fix this. So the last thing is to actually now load the ontologies and connect them to the chain, like we did in the Ready project, going back up to the supply chain and the BFO. Actually, I've just found a paper. Barry Smith advised me yesterday from that Hedy was involved to how this mapping has already been done. So I have to change everything. So now I changed it because I didn't connect to the supply chain ontology, but I will load it so you can actually see it. So I think we just clear the screen now because it's a little bit bloated. And what I will do is I will load all the instances of the same building. No, all the instances of the facade of the same building, of the southern building. Yeah. So these are the instances, and this is of course not very useful. But I can go up now the metadata, like the hierarchy up in the subclasses. So if I I have to load the ontology as well because now it didn't find any connections. So if I load the IFC and I load the supply chain ontology, yeah, you can see now that it's shaped. You have some clouds of the instances, which means that they are grouping around their class. And somewhere in here, I can see a blue one. It's the IFC class, but of course, I can take a small one here. Here's the IC curtain wall, and there are the instances going around. And I will just click a little bit more in the to go up the hierarchy, class hierarchy. So I can get up to see if I can find. You can see the namespaces or the prefixes are loaded here in the from the file. Yeah, I think we better go up one more level. So far, no crash. That's good. It's not very easy to find it, but okay. Let's click one more time, and I hope to see the green one there from BFO coming up now, because we are chaining it back now in the IFC hierarchy, and so basically working with this cloud in the center somewhere, there would be. Here it is. So yeah, here you can see the hierarchy. We're going from material entity. Hey, don't move away. Yeah, to the IFC element, which is a very abstract form of thing that is a material entity, and then into the IFC building element, and then yeah, further down the hierarchy. So the last thing, I didn't really have time to do it, but I want to do this, and I have expert help now. So I'm so happy about it. Also talking with with the supply chain ontology. So if I load that one. It's freezing up. Well, yeah, here it is. So I can now see that I loaded all the classes that we are not using outside of this cloud, these clouds. And then here are the orange ones. These are the classes from the supply chain ontology. And of course, now it's an interesting thing to look at the building model and figure out in the context of supply chain, how do we apply the supply chain ontology to the building when it's in flux, because it's like construction basically. So things are moving around, and then at some shape in time we will fix the building and then it's detached, I guess, from the supply chain, or if it's maybe going to be hooked into a circular flow in the supply chain or something like that. So this will be very exciting to continue to examine. So I'm not sure in time how I am. I'm probably late, but I'm done anyway. So thank you so much.
Yeah. Well, thank you, Andreas. Thank you. We made it with all the data loading and everything, and with the streaming at the same time. Does anybody have any quick questions for Andreas before we go on to the next demo? In that case, how is the IKEA team? Are you ready? So the next thing we will see is a really exciting application that's been worked on this week. And literally huge progress has been made. I think that my colleagues from IKEA will be the best to articulate this. So we have Katharina Kari, Parna Ashok and Payne Piper from IKEA who are with us, and there was a colleague also working remotely with them. And I invite them to tell us what was the motivation, first of all, of doing something as a breakthrough as this, and then what were the results, or what were the really big impacts and changes that you observed as a result of this. So welcome the IKEA team, IKEA Interglobal Systems.
When Mikkel was asking us to join, and as part of the whole OntoCommons as part of the whole like OntoCommons demonstrator experience, what was really important for us was to, like, I think I remember I said to Mikkel, like, yeah, but are we going to do something? Like, are we going to actually make this concrete? And we need some like support and some ideas on how to work with or like how to kind of work with front ends regarding to this, and maybe even like network with other people who are working on exactly these same things. And so, and then another current that was that Aparna and her colleague Alexander came to us, or we kind of found each other, and we were talking that one thing that we still need to figure out much more is the digital handling of our, the ethical handling of our digital data and of personal data. So marrying those two things, I said, okay, what if we actually take this digital ethics thing that we want to do and take it to OntoCommons? Like, we could spend a week in Oslo prototyping something we haven't yet seen, and there's something that just, like, it wasn't existing on a contextual level, it was existing more like the intention level that, hey, we want to do something with digital ethics, and we think that the interior designer knowledge graph information that we already have might be the way. So we weren't really sure, but we just had a hunch this could be it. So, and Aparna is going to take you through our presentation where she's going to show you a whole story on how we did that, but that was the initial spark for this whole collaboration and us coming to Oslo. Yes. Okay. Yeah. Let's just make sure you're visible here.
Yeah. Right. Okay, so we've taken a bit of an approach, a holistic approach of saying, how do we use knowledge graphs for a business outcome of how do you make, how do you personalize shopping experiences, and how do you do it in a way that gives customers choice and agency. Now, as a state of, what are we starting with is that we have lots of products and there are lots of add-ons, but how do we help everyone choose? How do we navigate it as customers? How do we navigate it as a business? How do we support this whole process? So let's, from the as states, let's look at what are the problems that we're trying to address. So customers want to be able to have a personalized journey and get what they want without giving away their privacy. As a business, we want to give very give recommendations that assist that journey in a way that helps them take good decisions, but also in a way that we can make it a bit less opaque, so that customers can approach our range and we can personalize it at scale. At the same time, EU regulation. So I think we probably over the last couple of days, we've talked quite a lot about Data Act and Data Governance Act. We're also interested in looking at the Digital Services Act and a little bit of the AI Liability Directive of how to make recommendation, how do you work with recommendations. And so the kind of aim, how we scoped this exercise was to say how, let's develop a prototype where we take knowledge graph and just in-session data to deliver a personalized experience to customers so that we can also uphold their choice and agency. Of course, it's an experiment because we don't know how it works, but that's what we tried. And this is kind of the scope of the experiment, where we said, okay, can we deliver this and how do we do that? And this is the way in which we've approached it, right? Customers come as you are, and we bring what we have. Customers can share as much or as little information as they want. So that's taking a first-party or zero-party data approach. And as IKEA, we do have really good interior design knowledge, and we have the fantastic knowledge graph, which encapsulates some of that. So how do we marry these two together to truly give agency, and how could that work? It took quite a bit of pre-work. We spent quite a bit of time before coming here to see how this all scopes into one prototype. And the approach we took is to say, okay, this is an anonymous user, no cookies, no trackers. How do we use a very limited number of parameters to contextualize all the things that we offer to help people meet their needs? So then, the journey is triggered from only a few pages. So we've also got to see where we have all of the data already gathered. And from there, we've taken a progressive, transparent, and intuitive recommendations as an approach. And yeah, this is quite exciting. And then now you can see what we actually came up with. This is how we arrived here. And over to you, Tim.
That this is completely coded.
Yeah. Yes, exactly. Okay. Yeah, so we came together with the Knowledge Graph team, and we decided to actually try something on IKEA.com. Now, we don't have control of IKEA.com as its production site, so what we've done is we used a Chrome extension, and we've built a front-end component on top of IKEA.com. So it uses the real IKEA address to understand the context. We've also built a small API locally, just to do this. So we have Sparkle endpoints that have been created by Katarina, and with a little Node.js server that we've just built over the last couple of days, we've built some URL endpoints that allow us to send the URL of the page that you're on, and that will give us the context. And then some other endpoints that will make more sense once we see the demo. So you're on IKEA.com, and you've decided you want a new sofa. So you go to Shop All Furniture, and you pick your sofa section. And what we're doing here is we're just popping up this little window on top of the site. And we're saying here, welcome, you're an anonymous guest, and this is an anonymous session. But what we feel we can do is we can give you some recommendations based on some questions. So here, with our product categories like sofa, we have appropriate rooms, and we have appropriate activities that we see with it. So if I was to select my living room, you can see here that we're getting product categories for the living room, and we're asking the customer, do you want to personalize further? So these two at the top come from the context of where you are on the site, but these two come from the context of the products available. So as you can see here, we have nearly 1,500 indoor sofas, 150 sofa beds, 1,300 fabric sofas. So there's quite a lot of products and choices here to look at. So let's have a think about what we want. So maybe we like a style. Maybe we like a Scandinavian style. Well, great. We've only got 350 sofas to look through now. Maybe we like a American country, 44. And here we can say, what's our budget? Maybe we have a medium budget that we can go with. So here, yeah, Stradamon, for example. But maybe we'll have a bit of a thinner wallet. So maybe we just want to go down a level and see. And now we're looking at them, we're thinking, not fond of the colors. So maybe let's go back to contemporary. So all of this is based on the recommendation of the customer giving us some context of what they would like to see. And here we can actually even filter it down by activity, because we can see sofas that you socialize with, but maybe you just want a sofa bed for your living room. So with this, a little bit of a network connection, slow issue going on, but yeah, of course, this would load the data.
This is a perfect time to mention that also all of this is on live data. So all of this is actually on top of our one core GraphDB that's in stage, because that's where we developed our prototype one. So just,
yeah. And of course, we have other products as well. So maybe along with the sofa, I want to think about, do I need a new work table? So maybe I'm going to have a look at my living room for the tables and see what we have. Oh yeah, I can get a laptop stand. Maybe I want to look at dining room. Yeah, got some dining room tables. And here, again, we can filter down by style and price. Okay.
What I'm happy to do now is to then also walk you through how we actually put this into the ontology. Then I have to log in again. Okay. Shoot. I need to relog. I need to stop sharing the screen for a while. Yeah.
If I log in, is it will show the same thing?
No, you don't have edit. Right.
Okay, you got your laptop. Explain, do you want to tell us, so how much have you been, how much of this has been written while you were here?
All of this code has been written while we're here.
API.
So the whole API, the first couple of days we were working on the API side, working with the Sparkle points, and pretty much most of this UI was built yesterday.
Actually, let's, while I log in, let's share the screen of the diary in our present. Yeah, okay, we'll just log in. Yeah.
If anyone has any questions in the meantime.
This is the perfect time to ask 10 questions.
Yeah, so on the
just remember to repeat the question to the microphone. Yeah.
Yeah, so on the top it said that the session was anonymous and you can choose whether to save your data. So you didn't show where that is, but is that something that happens like after they add something to the cart, or?
So the question is on the text that said that you would be able to save your data. Unfortunately, it's a hackathon. We didn't have time to finish it.
Oh, okay. So what would that functionality, like how would that work? Would you invite the user to create an account and save their data, or?
Potentially. I mean, from a UX perspective, I think that's something that we'd have to figure out what's the best way to do that. But for us, the point was that all of these recommendations, we're not using any cookies, we're not using any unintended data to try and figure out what a customer wants. We're actually asking the customer explicitly, what it is their needs are.
And a kind of follow-up related question. So in the presentation at the beginning, you said that it would be a transparent experience. And so is that what you mean by transparency? You're telling the user right at the beginning that, hey, this is anonymous, you have your choices. Is that what you mean by transparency?
Yeah.
Question?
So in this hackathon,
Please repeat the question.
Yes. How do we do transparency was your question, right? Yes.
Well, I was asking if that was how you implemented transparency, was by notifying the user.
The question is if we do transparency by notifying the customer. So transparency is a principle, and through this prototype, we're also trying to see how we can, what implementation and practices for that look like. So one thing, one feature that is important in this experiment and something that we would like to take forward is to say if it's just in session, one is that, yes, what data you give us here, you know what we're asking and you know what you're inputting. So if it does get more sensitive, we're not assuming things. So that makes profiling a bit more transparent. And the beauty of knowledge graph there is if you give us a certain piece of information, we can show you how that connects to your recommendations because there's semantic data there. And there's a few more ideas in how we want to take this forward. So when the session ends, they can potentially, and this is an idea, we haven't tested it yet, is to say, do you want to just take your products and go forward, or do you also want to save your inputs? The whole idea of keeping this in session and anonymous was so that we can create that boundary and make that a very intentional jump. We still have to figure out technically how we'll implement it, but that's the thought process as we go through this.
And maybe just one thing to add to that is we didn't get to finish one of the other features, which we'll show the ontology side of it. But for example, if we ask you if you're living with children, maybe that's a sensitive question to you. But by doing that, if you give us the answer, we can give you more relevant products based on that.
And then it's up to you if you want to actually save that or not. Yes, please. Yep. Gentleman in white. Yes. White shirt first.
Yes. I'm completely ignorant about these, how it works on, let's say, on an existing site, or maybe even on your site today. I can do these down selections. It's for this, so in the future, right?
So the short answer
comes with all cookies.
Yep.
I mean, there's a huge amount stored, I guess.
Exactly. I mean, the question was, how is the industry standard now? How is it being done? And I cannot actually speak much for IKEA.com since that's a different company that's running it. But having worked in Zalando as well before previously, I have some inkling to how it goes. And basically, the idea is in those cookies, everything is stored. You have huge amounts of data, and then you have data scientists scratching their heads and trying to mine for weak signals, what we call weak signals. So I think there was like a whole army. There was a team, at least a big team, that was focused on customer intent, and they were scratching their heads for a long time. I sat next to them. And so what we're doing is the opposite. We're approaching customers with strong signals. And it's really it's the same experience we have in the store. You don't want somebody who's your stalker to greet you when you come to the IKEA store and smiling to themselves. I think I know everything about you, and I'm just going to talk to you and give you these things. I'm just going to appear next to you and be like, this is what you want. You don't want that in the store. Why would you want it online? And that's what we are saying, that actually we could just turn this whole thing around and be a little bit more direct.
Yes, but then you also want
to. Yes, please.
I think you already answered me. My question was, what did you think is the greatest benefit of using ontologies instead of traditional relational databases?
Exactly. So the benefit of ontologies and then the instances following those ontologies is that we can craft a straightforward, transparent experience that actually asks upfront and knows what to ask. So we've done it like Tim showed it. It's contextual and sensitive to the URL or the place in the IKEA.com where the customer currently is. So these are sensitive to the area of sofas and so on. Yeah.
And I would just add one thing. In the store experience, a lot of when you go in to buy something, you speak to our co-workers, they'll spend 10, 15 minutes with you asking questions, trying to find out what your situation is, what your budget is, and the size of your property and your living situation. And that's there to help you. So we're really seeing that as the extension of the co-worker into the digital space.
And actually, so if I kind of run through the ontology, what you're seeing here, the product category with all its like properties. So this is a shackle shape representation, and these are classes. The boxes are classes in our ontology. This part was developed for us to recommend accessories to products. And that's where we hosted a lot of interior designer knowledge. Now we're building on this interior designer knowledge, and during this hackathon, we made this extension. We said that we're going to track the complementary and essential things or the activities that are essential or complementary to a product category. Product category would be sofas or tables. And we're going for all room types that we have, we're going to say which product categories they host. So a living room would host a sofa, etc. And this information was added during this hackathon. The ontology was created during this, well, this bit of ontology was created during this hackathon, and all the Sparkle queries using it. This is actually what was done by our knowledge modeler, Sandra, who sits in Malmö, supporting us, together with Adam, our business owner. Together they put this up during this week. So this is basically all the rooms and activities and their connections to the product categories. And this is the tool where they visually connected them. So they took things in and then drew the lines according to the shackle shape defined in the ontology you just saw. For example, so they did this part for the sofa, for example. The sofa, this is already pre-existing, has some some subcategories. And then sometimes the subcategory is connected to the activity, sometimes the super category is connected to the activity, and then the living room connects itself to these back to the product categories or the subcategories. And then what I did is I said, hey, let's take sofa, let's take table, and let's take bed for this presentation, for this hackathon today. So what I did is I took all of IKEA.com's product catalog, which we call categorisera. I took that and connected it to the product categories. So this sofas with the picture on it, that's actually IKEA.com's taxonomy. I mean, it's their product categories, their static way of presenting product categories and product categorizations online. I got it as a JSON dump and turned it into a SCOS taxonomy so that I could connect it with our own product categorization. So I could get the counterparts. This is a little bit like Alzheimer's, although Alzheimer's is made for classes, but this is the one for instances. And so what I can, if I want to bring in a new page, all I actually have to do with all the work we've done is just create this connection, because the work's already done for the categories. There's so much pre-work done. So all I have to, if I want to bring in now cupboards, I'll find the cupboard one and just connect it to the equivalent cupboard product category, and it will work for cupboard as well. And this was what we achieved on the first day, already this connection and being able to return something in terms of the API. Here you have the same thing for tables and for beds. And one more thing that we did is those styles that you saw, we have some secret IKEA styles, which I will not show to you today because that's our trade secret. But we connected them to a customer language of styles, so that we can expose. We came up with like a few, general knowledge styles, like American country or contemporary. That's not a trade secret. And then we made our own mapping to our internal secret ones. And this way we could then now speak the customer's language. Yep.
And if you were to add like more kind of types of customer rooms, like you mentioned children and things like that?
So children's room is already added here in the data. That's already been connected to the product categories. We have a few rooms, like something like around 10 rooms that we have identified that we're working on with IKEA. So all of that data is already in this big one connected. So if we would enable something else now, yeah, it would work out of the box.
What is your estimate on the saving?
Okay, so Michaela was asking what the estimate is on the saving. To bring a feature like this, or to create an experience like this, is like half year's work at least. So the saving is actually, I mean, it took our team to create the initial knowledge graph infrastructure also half a year. But after that, we can be so much faster in creating. Like, we did this in a week. No, we did this in 3 days in total.
Not even 3 days.
Not even 3 days, because we were mocking about on Wednesday. So not even in 3 days, but we could like, the time to deliver a feature is increased by months over like at least 5 people. You do the math of what the average salary is for a software developer times 5 times,
as well.
yes, exactly. So there's like some, if you do new features, you sometimes have to go through rigid data migration projects because the data isn't there. But now the data, like this took the 1 day to create this canvas, to create all these connections, and then the data is available. And whereas data migration is a matter of months. So there's no need for data migration. The only need there is to connect it in the knowledge graph, and then it's plug and play from there.
And so you can effectively calculate it in terms of carbon footprint on the data as well.
That's true. So there's a carbon footprint consideration here as well, because actually this is the amount of ontology and taxonomy information. And this, what you're seeing in RDF, that's like a few megabytes. And 1 megabyte TTL file, what you're seeing here on the screen. Like not one, like 1 TTL file, that's a matter of like maybe magnitude of megabytes. Maybe it's actually 100 of kilobytes or something, or even 10 of kilobytes. I top of my head, but something like this is the magnitude, and that's not a lot of data. Whereas with migration, it's the data is somewhere, and then you copy it into this other format, and so on. I think, but then the Sparkle calls and caching would then need to be honed, but it's more like, imagine you're trying to get to this intelligence with data science. That's a very model that you need to train for months. Again, that's a lot of CPU, a lot of GPU usage. And then the model in itself, to host it or to make it available in the cloud with like MLOps, it's much more expensive to run statistical models than it's just to have these things. And this thing can run even on Blaze Graph. So it can be even that cheap. Yes? Question, please.
Last comment what you say about the carbon footprint, but I mean, any data represented as knowledge graph is much more heavier than the traditional, say, database, or even say NoSQL, MongoDB, or stuff like that. It is much more heavier in that sense. So it actually begs the question of why you do that. But then if you really want to do that, but then there is also this BDA technology where your data stays in the database.
Yes, but that's what I was, okay. So Argopoulos was asking the question of if that if you have all the data in a knowledge graph, it's much heavier than having it in NoSQL or other databases. See, I wasn't even talking of this data is not in the data graph. This is a taxonomy. This is a TTL file with a few triples. I'm talking about that, but I'm always talking that the level of intelligence here is on the ontology side, which is little, and on the, remember the 3 layers that I showed, and on the taxonomy side, but where the product data sits doesn't matter. For this purpose, for this prototype, it's sitting in it's sitting in a graph database for convenience, but it can be virtualized easily, and we can, and so then that's not. The knowledge graph approach is more like, it will be an ontology taxonomy approach with a virtualized knowledge graph, and then we're back at a much lower carbon footprint. Yeah.
And then, of course, there's the agency that you're giving the customer.
Yes, and then there are the ethical things that we have created
so
here.
At least 3 levels in which you calculate the benefits.
Yes, and the kind of there's also one more benefit, a financial benefit, which is the time to market is very small, but an additional because we can like quicker get it to the market. We can also test its feasibility. So if it doesn't work, we can also kill it faster. So there's a multiple there. But I think I've taken enough time. It's
Yeah, sure.
yeah.
Well, no,
So,
this has been
yeah.
this is good, and it wasn't you were planned for this kind
Yeah.
of time. So thank you very much to the IKEA team.
Yep.
So this is just to demonstrate what can be done when we apply thought into practice. I must say that there have been lots of consultations happening with some of the ontology experts. For example, Barry Smith sat with the team yesterday for quite a long time in there, and we had lots of other people making suggestions. But it's also great to see just what an incredible difference we can make at application level for huge manufacturers and suppliers, such as IKEA, when we apply some of the principles that are developed in this project and to real use case scenarios. What I'm really interested in is now how the team takes it forward, and also how they will be able to present it to their in-house teams, management teams, for example, in terms of the optimization, efficiency, carbon footprint, customer satisfaction, and all kinds of other impacts that have been achieved because of the implementation of the sort of principles that we've been discussing here for the last week. The next presentation we have is from Lan. Lan, are you around with us? So Lan has been working with Sourcons together with Claude, and they've implemented another step to this. Do you want to come and Lan from most familiar to most of you from TU Galway, who has been working with us on particularly on the work package on tools for OntoCommons.
Your floor is yours.
I have people helping me to set up the slides, the presentation. I'd like to give a very short introduction to the story why I'm doing this presentation today. So it wasn't planned. Initially, it wasn't in the agenda, but then I met Cloud on day one, and then I sit with him together, and then I know nothing about Sourcons before, so I spent one afternoon with him to learn Sourcons, and I offered him my own ontology. So we kind of collaboratively developed something together. So I'm going to share this personal experience using Sourcons in one day. It will be a very simple showcase compared to IKEA and his team, her team, Katarina's team, and Andrea's case. But yeah, so this is my personal experience I would like to share with all of you. I call it a hands-on experience with Sourcons in one day, but actually it's one afternoon. I personally feel that it gives me visualized engineering support for the entire ontology lifecycle, and I'm presenting from an ontologist perspective because as a user, I consider myself as an ontologist, but Claude would like me to mention that Sourcons is not just for people who understand ontologies. You can also have a data management perspective when you are using Sourcons. Okay, so yeah, I think just to mention that, ontology lifecycle, it's a typical iteration process. We start from maybe collecting requirements, but the process is never ending, in my opinion. We have to update the ontologies not very frequently, but it needs maintenance throughout the lifecycle. And this may be more clearer from the LLT methodology as Maria presented yesterday. We have 4 phases defined. So we recommend people to start from the first phase to define their requirements. People who are using LOT methodology, they are aware of this phase. But for people who are not using the methodology, maybe they started with their requirement definition, but they are not aware of it. And I have students who are learning ontologies with me, and they got most excited when they have those hands-on encoding using softwares in the development phase, the implementation phase. But we don't, recommend people to jump over the requirement specification phase. But people started to understand ontologies better when they are defining classes, properties, those components of ontologies. My point is, during the implementation phase, we have different activities that are conceptualization and then coding, reusing, evaluating. So these steps are these steps will bring people the awareness that they are actually developing the ontology. And the starting point of this development usually starts from three sources. Well, approximately 80%, these three cases will cover all of the starting points. So sometimes you will have a data set at the starting point. This is very common for, I think, industry. They have a lot of data. It could be Excel spreadsheet, it could be databases, and etc. But the second starting point is a conceptual model, which may be entity relation model, UML model, or just the scratches, which maybe stays in your head or you scratches on the paper. And the third and starting point is you have some sort of ontologies to start with. This could be all kinds of different types of ontologies, like OWL files, RDF files, turtle files, or you have triple stores, or you have already designed some SPARQL queries that you want to execute. But the ontologies, in my opinion, my own ontology even, I think they're not perfect because they are in need of my editing, in need of my maintenance for all the times. And in OntoCommons particularly, domain ontologies are in need of alignment. I think Barry Smith mentioned this yesterday that, manufacturing ontologies, they need to talk to each other, they need to be aligned. So Soluzons actually supports all of the three starting points. What's better is, I think, the visualization support it provides, for me, is amazing. I put this painting and I showed the slides to Cloud this morning, and he said this is the art shows people are horrified by something, but this is amazing for me. And he said maybe people who start with Soluzons with knowing nothing about it started with horrible, but then you get to know the amazing behind it. Okay. So the demo case we have is with my ontology. So my starting point is I already have something developed is in ontology shapes, not data set, not conceptual model. The supports that I got from Soluzons are as follows, listed on green, but it's not a complete list, but the points that I think are most attractive to me. First, it shows the power of showing the ontology stacks, the OntoCommons ecosystem, TL, MLO, DL stack. So clusters of classes of the three levels can be shown automatically, visualized on the screen for me. And for implementation and validation activities, I can use Soluzons to analyze the properties, domain, and range. I can reasoning classes, define the restrictions of classes. In Soluzons, they call it restrictions, but many people prefer to use the relationships, this term. We also can define axioms in a visualized setting. The third point is, I think Solutions is helpful for people who want to reuse ontologies because it's available on industry portal. People who wants to know what are out there, they can go to industry portal and then visualize the ontologies. I will ask Cloud to present this slide, the Solutions in the future.
I have to share.
No, just
Yeah, so do
What?
you want to explain this?
Yes. By now, Solutions is still an experimental tool because we developed it by ourselves with the help of some people, external people, and students also. So you might find bugs when you use it, so it's because it's a prototype. But we plan to, as it has some success, as the concept has some success, we will invest, and you also, I guess, we will create a non-profit organization soon, this summer, and provide to support a community of developers and users, and also online access to Solutions with different level of services, with public ontologies that will be almost for free. You will have to be on to log in, to have a login to get access to it, and different level of services, including industry and private ontologies with professional use and with different levels of membership in this community. So we'll do it this year soon. And if you are interested in joining this community, you just send us a mail and that will be okay. Okay?
Okay, now is the show time.
So I have to share?
I will stop sharing first, I think, from this machine.
Yeah, on that one.
A very short.
Just click stop presenting. Okay, stop presenting.
And I have to share?
Yeah.
Yeah?
Please.
This one. Okay, so I will do a very short demo with this OCRS ontology that imports, it is a domain ontology that imports a middle, you call it middle ontology?
Middle level ontology.
Which is IOF core, of course, and BFO. So I will begin to show BFO. In this tool, there are several tools, but this tool is Lineage. It's called Lineage, that's its name. We have strange name in Solutions, so but this one, okay. And I will, no, I come back here, and I will take BFO and show the classes from BFO here. And how they are organized as a taxonomy based on the RDFS subclass of property in that case, but it can be the taxonomies. They can be put for any predicate that could be type, that could be part of, and so on. And you see the taxonomy of this BFO that you know already. And what will we do here is to show the domain and ranges of these classes. And here you can query on any. This is a quite advanced query generator, SparkQL query generator, and we can see all the ranges and domain for this nodes. You can have the different kind of nodes you select, and it will show for each node the ranges, and we will show also the domain. And what I want to say here is that the spatialization is very important because, as you can see here, the spatialization of the graphs, which is the way we represent the nodes in the surface of what we call the whiteboard in the middle, where you can play, is based on the number of edges that each node has. So when you have many edges, you have you are in the middle, and when you don't have much, you are at the bottom. So this is a way to represent things. And if you take any node here, for instance, you can see the information of the node, okay, like this, okay, and with the restriction and all the information. This is directly imported from RDF, XML RDF format into Solesence and is stored into a Virtuoso SparkQL server. Okay, this is for BFO. If we look at, we can clear. This is a whiteboard, so you can clear when you want. And you will work with a selection of nodes that are in the whiteboard. And I no, it's not BFO. This is, I will take.
Now it's the domain level, is it?
Yeah, at the domain
middle level.
Middle level, which are we do this also, and we will see and all the, you have nodes here at the domain level, okay? Well, you can see this. What then? What will be interesting to show is at the domain level ontology.
Yeah.
I will share this and show this, and you have much more nodes, and we can see all the lineage as you said, like this, and you can see here some orphan nodes, so you can investigate why they are orphan. And what is interesting here, just to finish, not to be too long, we wanted to show there is a search engine. Each node is the label of the nodes, RDFS label or SCOS label. They are stored into a search engine, and it's very convenient to find to get complex searches between several ontologies. Each ontology has its own index into the search engine, and you can combine all these values together. And if I take, for instance, here a document, search for document, any kind of document in the current sources, you can do it also with regex into the SparkQL server, but it's better to do it with the search engine. And if we take here, you have the lineage of the node, because each node is stored in the search engine with all the superclasses, all the taxonomy, all its taxonomy. It's very convenient to do this. And we will see the info for this node here. And we began to work on the axioms visualization. And if I do this, I will be able to see, starting from this node, all the dependencies of this node. That it's very recent. It's not yet completely mature, but you can see that you have you start from this node, and you can see how it is composed from this property. So it is this one, and you can go there, and you can explore the nodes at different levels. Start from one node and see all the lineage you can go quite further. It's not okay. And all these graphs that you visualize, you are also able to export them into CSV if you want to use them in a traditional way, I would say. Okay.
Which is also very helpful, the traditional way. So the Solesence can provide visualizations, but also the tabulars that people are very much like. So I have one more slide just to summarize my lessons learned. Sorry about the delay. So my lessons learned from the one-day hands-on session, I would say a master class with one of the original developers of Solesence are the following. First of all, I am aware of the importance of the consistency in IRI, because when we upload my ontologies to Solesence, my ontology contains top level and middle levels. The middle level IOF core is the latest version. And all the IRI starts with spec, but what is within Solesence is one version, like one old version. All of the IRI starts with, I think, permanent URL, URL, yeah. So we couldn't find any matches because this inconsistency. And the second point is the version management or configuration management of ontologies, especially for upper level ontologies. But I'm not saying that domain level ontologies configuration management isn't important. It is. That's why I think the bridge concepts are very important, because once we have defined the middle level and domain level bridge concepts, and they are well maintained, have a permanent IRI, it doesn't matter the ontologies that you are using. If you just use this bridge concept, it won't change. So this is the second point. And the third is, I think it's important that we follow a well-designed methodological framework, for example, the LOT methodology, and we do need your feedback on this. There is a small survey that you can participate in to give us your feedback about the goods and the bads. The last one is, I think tutorials and trainings are very helpful. Through like one day, I can learn how to use solutions. But if we don't have this kind of opportunities, there are videos online available to learn how to use it. It's better to try with your own data sets, your own model and ontologies, and then you get better understanding about it. So the last point, I think I echo ARCO's requirements. We want data sets from demonstrators, and we can show how this tool can help you. Yeah, so that's all. Thank you.
Brilliant. That was actually really comprehensive. And during this week, we've also had students interacting with the new tools in terms of working with ontologies and with knowledge graphs, so various tools, including solutions. And so there will be now short presentations by 3 students working with various different tools. So first, I invite Nasreddin Bouchamel, who is looking at complex intra and cross-ontology mapping in the industry portal. Nasreddin? Thanks. Christina, we might need your assistance on plugging the computer there.
Okay. I start?
Yeah, sure.
Okay. Okay. Welcome. Hello. My name is Bushmal Nasruddin. I'm an ARCO and HEDI student, and I'm here to present to you my work about supporting complex intra and cross ontology mapping in industry portal. So to kick off the presentation, I want to talk about something that maybe you already saw in ARCO's presentation, which is the industry portal. It is basically an ontology portal for industrial domain, which is a platform for hosting and curating ontologies, as well as it provides many features. In those features, we have the mapping feature. We all know that mappings play a vital role in the whole ontology world. They enable knowledge sharing and establishing meaningful relationships between ontologies. However, think they will hear now. Okay. As I've said, the outcome of this built web service for mappings, for complex mappings, one of it is, as I've said, we've been able to infer some complex relationships between classes, like maybe shown here. That say in this class dataset created from the software ontologies is equivalent to a planned process and has specified outputs and dataset. And also, as we said, we will enrich the mapping, so we'll be able to add more data to the mapping table, talking about contributors, authors, the mapping justifications, and etc. And of course, as we said, we've been able to support contextual mappings, offering the display of OntoCommons ecosystem-specific mappings and the contextual mapping-based grouping of mappings, and eventually the possibility to store those mappings in our RDF files. Well, thank you for listening.
Thank you. Thank you, Nasruddin. Next, we have Emna Lakani. Emna, please come and join us. She's looking at the insights with the KG Creator, redefining data mapping for semantic excellence.
Hello everyone, I'm Emna Lakani. Today I'm pleased to introduce you to KG Creator, a powerful tool that is transforming the way we approach data mapping for semantic excellence. So KG Creator is part of Sous le Sens vocable tool. It has been developed to simplify the process of data mapping and unlock the potential of semantic web technologies. KG Creator empowers users to effortlessly transform their data into a more meaningful format. By mapping data to RDF triples, KG Creator plays a vital role in constructing comprehensive knowledge graphs that facilitate deeper insights. So in my intervention, I focus on the standardization of data mapping using the RDF mapping language, RML, within KG Creator. Actually, RML provides a standardized approach to mapping data from various formats to RDF triples. So why we made the decision to transition from using JavaScript function or Sous le Sens vocable functions for data mapping to RML in KG Creator. So the first reason is standardization and compatibility. RML standardized specification ensures standardization and compatibility by implementing RML within KG Creator. We ensure seamless integration and compatibility with other RDF-based tools, promoting data sharing and collaboration. Adaptability and scalability. KG Creator's utilization of RML allows us to handle diverse data formats and efficiently map large and complex datasets. Incorporating RML into KG Creator ensures that our projects stay up to date with the advancement in semantic web technology, enabling long-term viability and growth. So here's some results and screenshots. Actually, KG Creator simplifies the data mapping task by providing a user-friendly interface. It's, let's say we have tabulate data in, for example, CSV format that we want to map to RDF triples using KG Creator with RML. After importing data, the user select as input a subject, a predicate, and an object. So RML mappings are generated dynamically, specifying how each column field should be transformed into RDF triples. Once the mapping are defined, KG Creator will use the RML processor to execute the mappings and generate the corresponding RDF triples. Sorry. So, Cache Creator, powered by RML, offers a powerful and user-friendly solution for data mapping, but it's important to note that RML may have limitations in covering all possible mapping scenarios. For instance, to relate, for example, a blank note to each line of data, it is often necessary sorry. So I said, for instance, to relate a blank note to each line of data, it is often necessary to assign a unique identifier ID and indicated in the mapping definition. So Cache Creator addresses this by providing the flexibility to customize mappings as needed. Despite these limitations, Cache Creator enables efficient mapping to RDF triples, compatibility with other tools, and the ability to derive valuable insights from data. Now, as next step, integrating Cache Creator with GraphDB enhances user capability, enabling seamless data handling, advanced search, and exploration. This integration improves the Cache Creator experience, empowering users with semantic web technologies for valuable data insights. Thank you for your attention.
Thank you, Enna. And finally, we have Amin Karoui, who is going to speak about supporting axioms in reasoning in Sula songs. Welcome, Amin.
Hello, everyone. My name is Amin Karoui from Tunisia. I work with Hedi, Arco, also Claude, under Solutions project. So let me talk about the lineage tool. First of all, Solutions contains a lot of tools integrated. One of them is lineage. My colleague Emna spoke about Cache Creator before. So now I'm speaking about lineage tool. Lineage is a tool developed inside Solutions. It's been developed to visualize, edit, and manage RDF graph. So I'm gonna show you some screenshots that Claude already with Ian showed you a little tutorial. First of all, this is the interface of lineage tool. So as you can see, you can import import a lot of sources. For example, here I imported UFO and PFO. And as you can see, we can group both of them in for example, IOF and PFO, and you can see the relations between each others. The next thing we can do in Solutions, we can query through the nodes. So, for example, I'm taking complement of, and I'm trying to show what I can see after. So here, the results. So we can go next. We can search via the Elasticsearch tool. We can search through classes, properties, and so on. Also, we can export tabular data as CSV, as well as we can export the graph in SVG. You can use it anywhere else. Here, if we want to see some infos about node, we just right-click on a node, and pop-up will be shown, and like we can press on node infos, for example here, and we will see a lot of infos about the node. So my intervention here in the Solutions, it was in the integration of the reasoner. So in my case, I I developed the reasoner in another repository, and we use it as a backend API. So the reasoner, like API, for example, will check the consistency of an ontology. So for example, here we have this option in Solosens, so we can check the consistency of the ontology. Also, we can identify the unsatisfiable classes within an ontology. Also, we have that in Solosens, as well as reasoner use inference mechanism to drive new ontology from the existing ontology. Also, we have that in Solosens. So here, the interface to reason inference. So as you can see, we can choose consistency, inference, and satisfiable classes. But as you know, we can't get the inference that we want. Like that's why here we integrated SWRL rules. So Lineage is able to edit SWRL rules, which Cache creator will be able to execute on data later. So I will explain that. For example, we have person, we have has a sibling as XW, man will give you as brother. Let me explain that. If I suppose myself is a X, so I am a person, and Y is, for example, Emna or Nasro, because I have as brother. So if I am a person and me has a sibling as a Nasru, and Nasru is a man, then Nasru is my brother, and that's what we infer in Solosens. Another example. If I am a person and my age is greater than 18, so I am adult. So another thing that I was part of is the complex axiom visualization. So in Lineage, we are able to visualize complex axioms within Solosens. So here, what we wanted to do, and you can see we did that. So in Solosens, we can visualize complex axioms, and like we can add axioms. And when you click on a node, right click, like you can add an axiom, and here it will pop up, and you will choose the axiom type. For example, we choose it complement of. We choose the range, it's a class, the entity type, the entity origin, and we can show the triple. We save that later. And thank you for your attention. That's all.
So thank you to all the students. I would now invite Hedy to join me on stage to close a week of very exciting activities. So it was great to have some really interesting things, both in terms of experimentation and innovation, real-world applications, and also learning and education today. So this really kind of rounded off all of the discussions of the previous days. So I thank everybody who participated in those activities. And Hedy, maybe you would like to say a few words about the whole
I would like to thank the organizers, so Monia, Christina, Rita, and all of the let's say the facilities in University of Oslo for hosting this workshop. Also like to thank all the speakers for their very interesting talks, and also the attendees for the very insightful discussions. So it was really very great to exchange. This is the main objective of this workshop, is to discuss with the community, to show what we are doing in OntoCommons, to get your input to improve ourselves. Anyway, the outcomes of the project is the effort of the community, is not only from the project partners. As a CSE, our objective is to to come with outcomes coming from the stakeholders, different stakeholders with different backgrounds. So thank you again. Our next steps will be the roadmap. So I will ask you again to provide your input, because the last version of the roadmap will take into account the discussions during this workshop, the insights from this workshop, to be shared with the whole community and also to go to the policymakers. As we discussed, there is a lot of things to do. We need funding for that, from, let's say, public funding, but also industrial funding. We have to work together in order to reach the objectives and to resolve interoperability bottlenecks. This is very important for industry, for the European common data market. So also a link with what we had in this session, we have 2 more events in OntoCommons. Will be end of September. One of them will be hosted by University of Bologna, and the other one will be hosted in TARP, in my university. So all of you are welcome to join us. So what we plan is to have training on OntoCommons ecosystem. So you'll have training on top-level ontologies, how you can use top-level ontologies to develop your ontologies, training on tools, on lot methodology. So try to provide the full chain of OntoCommons ecosystem. So it will be planned for the, let's say, for the second half of September. So we'll be informed soon and hope to see you again. Thank you very much again.
And then I would say, let's not lose the momentum, because of course, apart from those trainings and apart from a huge amount of recommendations, roadmap and deliverables that we are now working on towards the end of the project, I think the momentum that has been generated by this community is tremendous. I mean, I think everybody has been surprised just by the level of uptake, the level of impacts that a small CSA, relatively small CSA, has achieved. It's very important that we don't lose the momentum. So this really shouldn't be one of those projects where once it ends, the momentum is lost. This is why follow-up initiatives really need to happen now. We need to look at what are all of the different follow-ups that we can continue working as a community, and also in the individual streams that have been created that have really gathered some speed during this project. So thank you, everyone. I think it's been a tremendous week. Thank you all.
Thank you.